Today we want to discuss what our options are for replacing Docker machine. To give a bit of context, we started looking at one specific scenario, which is AWS autoscaling. And the reason for this is those are pretty much our mostly high risk scenario at the moment, just because most people are using the Docker machine version, and that is not maintained anymore. And most people don't use our fork either, unless we tell them to do so. And we're also not fully AWS experts with Docker machine. So to give a bit more context to Grzegorz, we want to replace Docker machine just because it's a maintenance mode, and we don't want to keep maintaining that code base ourselves, because we have a fork to fix some problems, and we don't want to keep maintaining it because it's very, very costly from our end.
I know the problem. I've been involved in the discussions.
Okay.
Replaced.
Perfect. Okay. So
frequently in the past. So yeah.
Okay, perfect. So I won't. If you have any questions, then ask. I think what I'm proposing at the moment would be to provide a Terraform template to use autoscaling groups for AWS. And basically how this is going to work is you have a VM with GitLab runner installed, and it can pick up jobs. And then you have autoscaling groups from AWS configured, so it will scale out, and scale in depending on some metrics, right? It can be CPU usage, memory usage. It can be also metrics from the GitLab runner metrics endpoint, and it can also be time-based autoscaling. So for example, at 8 a.m. every morning, scale up to a fleet of 10 runner managers. Now, these runner managers will be running the jobs in that VM. It won't be spinning up new VMs or anything like that. And it will be registering new GitLab runners inside to the GitLab instance. And as soon as the VM is terminated, it will unregister the GitLab runner and to remove the VM. So we basically are migrating the autoscaling logic to the cloud provider VM. And the plan is to implement this for all the cloud providers, major cloud providers, which is AWS, GCP, and Azure. And the benefit with this, we also get autoscaling for Windows as well, out of the box, without integrating with more APIs. More APIs.
Use the same technique on GitLab.com.
No, GitLab.com. I first started investigating GitLab.com, and the POC that I was going to do is with Kubernetes and Firecracker VMs with Kata containers, but we discussed that AWS autoscaling for VMs is a more important problem for us to solve, because right now for GitLab.com, we own the Docker machine fork and we have full control over the stack, but our customers don't at the moment, because they can't modify a Docker machine if the AWS API is broken or something like that. But with GCP, we can, because we have the knowledge and we have the bandwidth to do so. But for AWS, we don't. Now, we also have to keep in mind this is strictly solving one problem, which is VM autoscaling. Like the cloud provider, the users can use the Kubernetes executor for autoscaling as well. And we have plans to improve the Kubernetes executor so it's more stable and more, it has feature parity with all the other executors. But some people are they don't want to handle a Kubernetes cluster, even if it's managed by Amazon or GCP with GKE, right? They just want a simple VM. If it's just a two-person shop, the VMs is just fine for them. So this is targeting those customers who aren't really familiar with Kubernetes or don't have the bandwidth to deal with a Kubernetes cluster. So if you look at my Epic, at the Epic, let me share my screen quickly so we're clear on what we're talking about. I identified deployment methods. So some of them are self-hosted, like on a data center, self-hosted running manual Kubernetes, and self-hosted on cloud provider VMs. And then GitLab.com, which is privileged containers and privileged containers. So what we're trying to solve with this specific proposal is self-hosted cloud provider VMs. Any questions so far?
Like, do I understand correctly that we do not want to ditch the Kubernetes solution? Like, it's simply as another problem we want to solve later.
Yes, yes. So think of it as what the distribution team is doing with GitLab Omnibus and with the Helm chart. They're solving two different problems for two different kind of deployment models, and we want to do the same.
Okay, and the last question that I have is, does it mean that a user who basically doesn't want to use Kubernetes will need to instead understand how to use Terraform?
That is correct, yes. We can hide Terraform as much as we can. Georgie already did, I wouldn't call it a proof of concept. He already started working on this, where you just run a Docker image and it automatically runs Terraform for you. And it just authenticates with Google API and so on and so forth for you. So we can try and hide it as much as possible. But then like this, using Terraform, we can instruct users using infrastructure of code. So we can integrate with GitLab's Terraform integration and so on and so forth. So we can have GitLab manage GitLab runners. So yeah, we will be exposing users to Terraform, but at the moment, what we are exposing users to is documentation, copy pasting, and so on and so forth. So that might be somewhat of a better scenario than what we have right now.
Yeah, thanks for explaining that.
I know Tomas has a lot of opinions, so if Tomas can verbalize some of them, and then we'll go through them. Like they're really good questions, so I don't want to put you on the spot. That's why I really wanted you in this meeting. So yeah, we can't hear you.
How about now?
Perfect.
Okay. Maybe let's start with the one that I've asked Monday other call. This solution is built outside of the runner. It's built around the runner, which makes it a totally different experience for the user than what we have with the Docker machine executor, where you just install the runner. The only requirement for autoscaling right now is that you need to install Docker machine binary, and your cloud provider needs to be supported by Docker machine, so either natively or by a plugin. You just install the binary, optional plugin binary, then put a configuration copied 1-to-1 from documentation, and it works. You have one runner manager that you need to care about, and nothing else.
Yep.
With this, we change this experience because the user doesn't touch the runner at all. So they need to know how to use Terraform, or maybe not know how to use. We may hide it, as you said, but they need to use Terraform. This Terraform will then inject the configuration, so the configuration form is way different. Now you could just install the runner on a host, create config.tom by hand, and it just works. Here you need to have a tool that will magically scale this up and down and put into the place. So this is my first concern that I see.
Okay.
The second one.
And do you think, just to interrupt you a bit, wouldn't it be the same effort as running Terraform as figuring out how to install GitLab Runner, register it, and so on and so forth?
Like in this case, I'm only concerned about the selling point.
Okay.
It's different when you have a user that already uses GitLab Runner, knows how GitLab Runner works, how GitLab CI works. Now he wants to auto scale, and you say, okay, install Docker machine or anything else that we will switch to, and use this configuration, or just use this configuration and Runner will start auto scaling. So you don't need to change your infrastructure when you want to move from a static configuration to auto scale configuration. And this was what we did with Docker machine. Like
Yep.
you could use exactly the same host, you just changed the executor, you installed one binary, and you started to have auto scaling with exactly the same runner that was running for past 1 year. And my only concern is that it is a way different experience, way different behavior, and I don't know if this will be as good selling point as it was with the Docker machine executor.
Okay. I think that's a valid concern for existing users.
Selling
But
point, interesting, but what do you think about the maintenance point? Because maintaining a Terraform plus a custom solution for AWS, it might actually get extended into maintaining the same or similar solution for GCP, many other like providers, and then suddenly you need to maintain Terraform compatibility for all of them. Then you suddenly need to maintain the complexity related with the differences between them, and suddenly you can have this proliferating complexity and maintenance burden.
Yeah, this is true, but I would not be as afraid when it goes for this, because with Docker machine or with any other uh, existing or created by us solution that would replace Docker machine, you still need to support multiple clouds. So if we need to support it by ourselves, I don't think it's a big difference if these are Terraform templates or cloud API implementation in Go, as we started doing with the autoscaler. If we want to be multi-cloud, we need to support multiple clouds, and this will never change. Docker machine was just so nice because it existed, it had a big community, it had a lot of existing integrations, and now we need to either choose something that works like that and has all of this, or we need to start maintaining our
Okay,
own.
so my question is like it's clear to me like why Docker machine was a great solution, but it feels like the solution suddenly is starting to decay, or it's basically disappearing. And how is the industry solving that? Because it seems like that's a very valuable solution that is no longer viable. I can just guess that industry might be solving that with Kubernetes these days, but is there like a different solution that people that want to use the cloud but not necessarily Kubernetes are like using? Like it's hard that it's disappearing and there's nothing in return.
Do you want to give a look at the history lesson on that, Steve?
yeah, I mean, if
I mean, I can, if you want.
yeah, go ahead. So I'm not the only one.
So I had the same thought like a long time ago. I'm like, what's everyone else switching to? Like, this provides value. There's got to be something else. And so after doing some digging, what I turned up is that for maintenance reasons mostly, because this Docker machine becomes a nightmare. Steve kind of put it to me the other day. Like, it's the integration, like integrating with all these really challenging services goes into this one place. So they refactored it or rethought it, rebuilt it, and it became something called InfraKit. So Docker actually made a new thing called InfraKit that is the replacement for this. Then they realized the problem actually wasn't the code and the architecture, it's having all these APIs supported in one place is just unmanageable. And so they just walked away from it. And so they've deprecated their replacement for this. and no one has stepped in to provide a replacement, because I think it's such a massive maintenance burden to provide a generic multi-cloud, like kind of general purpose cloud agnostic orchestration tool. It's chaos. Like no one wants to take on that maintenance burden.
And like what the industry is doing right now, if we look at like GCP and things like that, and Azure, for example, and AWS, is they are providing their own Kubernetes solution, right? And even DigitalOcean, like DigitalOcean for the longest time, never had an autoscaling solution, but with Kubernetes, they provided it that. Now, they're also abstracting Kubernetes away with the container runtime as a service. So for example, for GCP, it's Cloud Run and functions. And for AWS, it's like Fargate. And now Fargate is even more powerful by allowing containers, and also Lambda, because Lambda now allows you to build your own containers and run those containers. And that's somewhat like the Kubernetes experience, right? You just build a container and it runs it and you don't care where it's running, kind of thing. And now I know the question comes up like, why aren't we using Fargate, or why aren't we using Cloud Run for these CIs? And because those are lockdown platforms built for handling requests or HTTP requests, or like timed applications. It's not for building jobs. For example, we need privileged containers. Sometimes we need like jobs that can run for 6 to 7 hours. And if you look at Fargate, it does not support that long time execution. So does that answer your question, Gregor, or is it still not clear?
It kind of does, but it feels that the maintenance burden that Elliot is talking about is exactly something that we want to take on ourselves if we proceed with building this solution, because we will need to figure it out how to model that on other platforms, and then
exactly.
So please go.
And that's why I'm proposing using the autoscaler from each cloud provider, because then we don't have to think about the autoscaling algorithm and integrating that autoscaling algorithm to the cloud provider. We just use what they provide, and we just provide a template.
Yeah, as long as there are no differences between how.
Oh, there is. Yeah, there is, for sure.
Every other like cloud platform, and suddenly you realize that we might need to actually ship code to compensate for the differences, and then it gets even more messy. So that's, I'm not saying that we should not do something like we are describing. I'm just playing devil's advocate,
No, I agree, and that is a real concern, because, for example, one thing that is an issue at the moment is AWS provides timed autoscaling, so you can scale up at 8 a.m., for example, but GCP does not. And that is a real feature parity difference there. So, and we don't have any real solution for that at the moment, even with this thing that I'm proposing. But then maybe we don't really need timed autoscaling. So, because, for example, you don't scale up your Kubernetes instance on time. You scale up your Kubernetes instance depending on the load. And that's why I'm assuming GCP never really implemented the time autoscaling, because they use autoscaling behind the scenes for Kubernetes. So they just exposed that as its own service. But yeah, like we're still going to end up integrating no matter what. It's just the level of the level of integration we want to achieve, I guess, as well.
Yeah, so that's interesting, and I wonder if actually there is a way to simplify this somehow. Like, of course, I've been not thinking about it a lot recently, but perhaps we could restrict ourselves to supporting only few the most popular platforms. I know it's a product, it's product decision. It's like, something that we would need to think about. But then we can, for example, build a autoscaling module that we would deploy to a master node, and then only maintain a small API for creating and removing nodes. And this way, this integration scope for every platform would be much smaller, just creating and removing nodes, right? Like there are multiple ways of actually, reducing the amount of integration work and expanding the amount of generic work. And
yeah, adding nodes and things like that, that's interesting, because then, like looking at just AWS, right? For example, they add a new ARM CPU, like a new instance, right? Or a new availability group, or a new CPU architecture. From an API level, if we want to add nodes and things like that, we have to add support like, hey, we want to request this CPU architecture, and so on and so forth. But with autoscaling, it's a matter of just pointing to an AMI, and that AMI is configurable, right? But then we also have to look at intricacies like this, the flags that we need to pass. For example, recently we added GPU support for GCP on our Docker machine, and that required us sending some new data to the API, so request the accelerators and so on and so forth. And every new machine type that comes into play, we might have to update our API integration to
it makes
pass.
sense. Yeah, so it means that we wouldn't be able to find a small solution for adding nodes and removing nodes. It's
each node has its own configuration field from an API level, just because it's a low-level API. And
on the other, like, I'm sorry to interrupt you, but I know it's like we don't have a lot of time. But the another like idea of mine is that we should start with GitLab.com, because this will dictate building the most efficient solution, and then telling our users that you need to use this method. It might not be the most simple one. You might not be able to model that on cloud without Kubernetes, but we decided to give you only these because this will make everything much more efficient for you. We are running this on GitLab.com, and if you do this our way, you are going to save a huge amount of money for cloud. Like Kubernetes has been designed to be like cheap, because it provides this, better utilization primitives that we can use, and it's designed for like, increasing the utilization so that it's more efficient. So perhaps that's another way to think about that. But I do agree it's super difficult problem. So
yeah, I agree. I was thinking the same. Like, why not just go all in at Kubernetes and just provide an easy installation of Kubernetes? But then we see what the rest of the product team is doing at GitLab, right? If we look at like what Dimitri DZ is doing, he's creating a new 5-minute deploy application on AWS EC2, because some people find the auto DevOps with Kubernetes and so on and so forth way too complex. Or the release team is adding auto deploy to EC2 because auto deploy to Kubernetes is complex as well, and users can't just magically migrate from EC2 to Kubernetes as well, their applications. So it feels like we might end up going the same direction. No? Darren, I see.
I don't agree. I think from my perspective, we should be all in Kubernetes long term, and that the patterns for VMs should be as simple as possible.
Yeah, okay. But we still need to provide a pattern for VMs, right? And that's like looking at what current solution we have. Like, we have two solutions that I can think of: integrating with the API or just using autoscaling. And just using autoscaling from the cloud provider seems simpler than rewriting the API integration. We have to look at the past experiences we had integrating with cloud APIs with GCP for Windows autoscaling and for Orca. With GCP, like Thomas had a lot of knowledge with GCP API, and it still took around 2 months for us to finalize all the work. And the same with Orca, like it's still taking 2 months to integrate each cloud provider. So we also have to think about that. Like, yes, it needs to be a simple solution, but a simple solution needs to also be easily maintainable. Does that make sense?
yeah, I think it makes a lot of sense, but we just need to be mindful about, and we should understand that it actually might mean that we are going to spend a lot of time on maintenance and making this solution available for on one bigger amount of platforms. It's just this ratio of this balance between the providing the most simple solution for users and maintaining all the solutions. So like it boils down to like not there is no something like a free feature. Every feature we ship comes with a cost.
Yeah, I agree. To keep conscious of time, do you want to move on to the next point, Tomas, that you have in your agenda, in the agenda?
If we think we told all that it's to say for now. Okay, so my second concern is way more technical. From what I understood, from what you were telling, this autoscaling will work like we have in this case, AWS autoscale groups that are basing on some metrics, are creating VMs with GitLab Runner installed, and this GitLab Runner is registering to GitLab with a configuration that we templated in Terraform, etc., etc. This means that in a more loaded environments, we soon will get hundreds, thousands of registered runners.
At GitLab.com, we currently see a limit at around 2,000, and beyond that, runners are killing the database on GitLab.com. It's 2,000 per group. We cannot go beyond that because it's killing the database. So that's from the incident we saw a few days ago.
Yeah, and this is what I started thinking about, like looking on GitLab.com shared runners, they're running up to around 3,000 jobs peak during the day. So with that architecture in a bigger installations, and I know that at least some of our customers have way bigger loads than what we see on GitLab.com. It means we would have thousands of registrations, unregistrations, and existing runners. And registrations and registrations are maybe not a big problem. The same is, it would be harder to look in the UI and check all of the runners in the table, but this could be fixed. But our scheduling is based on the database, and everything starts with finding the runner and then calculating things in an SQL query, and having thousands of new runners during a hour means that the complexity and weight of the SQL query grows by an order of magnitude, which will become a technical problem that will be very, very hard to solve because we are already at the limits of what we can do with this scheduling SQL.
That's a concern I never thought of, and that's very true regarding scheduling and so on and so forth. But we also have to keep in mind, probably we won't see thousands of runners registered. I mean, these machines will run like 200, 400 concurrent jobs on the same machine. So it's just one runner running 200 jobs at the same time on that machine. So it's just one runner. So if you're running 10,000 jobs at the same time, it's not going to mean 10,000 runners registered. It might mean 1,000 runners registered, right? But again, I don't have an answer to that, and that's a really good concern that I never thought of. So thank you for that.
Yeah, and currently with the runner manager approach, this is quite simple because we have runner manager that doesn't do much, so it doesn't need a huge resources for the instances, but handles communication with GitLab and scheduling all of the jobs on the autoscaled VMs. And now switching to the model where every runner is a separate, really separate runner, I would not be as I don't think it will be as easy as the runner can handle up to 400 jobs. Like take a look that we have now a one or two CPU, 375 gigabytes machines on GitLab.com. We see that the average time of the job is almost an hour or even a little above the hour, which is quite long. And even for some of our own jobs for GitLab, we use more powerful machines because they need more resources. Now, if you want to handle multiple jobs on one machine with, for example, Docker executor, for 400 jobs, you would need to have a VM that have thousands of CPUs to make it efficient. I don't think it will work. So the numbers of concurrently running jobs will be definitely smaller. Like this will differ between environments, because if someone have tests that are running for 50 seconds and are not using CPU and RAM at all, they can put probably 1,000 of jobs on one bigger machine and it will work. But looking on my experience, these are not the average jobs that we see. Most of jobs are either long or heavy on using the CPU or heavy on using the disk or RAM. And then the number of concurrent jobs that we can use on a single VM is more and more limited, which means that we'll have more and more registered runners, and we are back with the SQL problems. So if we want to go this direction, we need to have this in mind, think how we can resolve this when this will become a problem, because it will.
Yep. I don't have an answer for that, so it's a really good thing you pointed out, to be honest. Yeah.
So if we're only thinking about auto-scaling within AWS, okay. Like we have to, what strikes me from this conversation of where things are at, it's like, we only want to solve for AWS, but we only want to solve for AWS in a way that's completely generic, and we can genericize, I don't know if that's the right word, I don't know if that's a real word.
We can build on top of the better.
We can do the same thing and turn it into GCP. If you were really going to solve this problem in an AWS specific way using ASGs, you would hook it to SQS. Every time there's a new job, the Rails application would put a message in an SQS queue, and the ASG would respond to that and create an instance based on that. So I guess what I'm really trying to say is, what are we trying to do here? Are we trying to figure out how to solve this in the generic way? Are we trying to figure out how to solve this in the most AWS ecosystem friendly way that like people that manage AWS resources are going to be comfortable with? Or are we trying to figure out what we're trying to do? And I don't mean to put you on the spot, Stephen, like gonna beat you up on that one, but it was kind of like comes back to like my point around Docker machine. And I think I think the Docker people walked away from it because they realized like this is a big challenge. Like you could probably start a company. I'm almost certain of this. You could start an open source like support revenue model company around providing a replacement for Docker machine. We'd pay for it. It's just put a contract in front of me. I'd pay for this to go away. Like this is a hard, big problem.
Yes, I agree. On what kind of problem we want to have, I'm just laughing at Aaron's message, sorry, to what problem we're trying to solve. And I would say this specific problem with AWS Autoscaling is only for this small developer team that is running 20, 100 concurrent jobs at the same time. If users really want scaling, like at what Thomas was saying, like thousands of jobs at the same time, then we probably need to direct them to use Kubernetes, because Kubernetes is more geared towards that.
Are we certain that a small team of developers actually do need autoscaling? Perhaps they can just install GitLab Runner on multiple instances on VMs, and that's it. Do they need to autoscale? Like, yeah, I can understand that they might want to reduce the cost, and especially on the night, on weekends. But like I feel like it's a lot of work that we would need to make to support small teams, and then it's debatable if we will be able to solve that correctly for them and maintain that for a very long time.
That's a good point.
And having this in mind, moving to one of the indentations that we've made in this point, I don't think we should, like I said, I get what we want to achieve with this autoscaling in AWS with the VMs, but I don't think we should name that this is Docker machine replacement, because
This is part of it.
we are targeting different cases here where when you really need autoscaling. When I hear that someone needs autoscaling, I'm thinking about thousands of jobs per day, because it's not only about costs, it's about the compute resources that you need to create to handle that load. When you need to scale to handle hundreds of jobs that will go in total during the day and who are not working outside of the working hours, then what you here propose to have these few VMs that will be scaled up, install the runner, register, start handling jobs, and then when the company is going off the day, everything turns down. Yeah, it would work, but it's not a solution for the problem that Docker machine executor was targeting. It's not this order of magnitude, and when we were discussing this in the agenda document, at least in two places, we've got to a opposite thinking that you say this is not a solution for GitLab.com, and I'm showing GitLab.com as the example. And I think this is because of that. Like, we started this discussion with how we can replace Docker machine, why we want to replace Docker machine. First is that customers are using Docker machine and it's unmaintainable. Second is that we use Docker machine on GitLab.com in a very huge load that our customers are doing, and we are suffering from the maintenance of Docker machine. And if we want to talk about how to replace Docker machine, we need to look on the scale that the GitLab.com with the shared runners is doing. If we want to target a smaller scale, then let's not name it Docker machine replacement. It will make our discussion easier, at least for me. And I think it will be also easier to the customers to understand what we are talking about. Because if we want to propose this to an environment like CERN, where they run thousands of heavy jobs every hour, they will quickly get back to us and say, we were looking for something different.
Yeah.
And I wonder if we, again, should start with Kubernetes and GitLab.com scale. And then we can think about users of this like vast landscape of cloud providers. And I can imagine building a small service that they will deploy somewhere with the requirement that they need to write two simple scripts to create a machine and to destroy this machine. And for them, it might be a viable investment if they want to reduce some cost. And we would not need to maintain, this part of like, integration to create machine or destroy machine. We just tell them that if they want to use VMs, they need to write a script for their particular infrastructure, their particular cloud provider, or whatever they are using to create or destroy a machine, or perhaps like get the amount of machines running. Like, it depends on how this thing should look.
Isn't that basically the custom executor? Like, isn't that kind of like, I mean, like we do a bit of the work, but like, isn't that kind of like what we've done with the custom executor? Like, you provide a script to like create the machine and then destroy the machine, and we'll make sure that we'll handle part of the job.
Like, I guess that the scheduler itself, like it's 99% of effort, how to build that correctly. Then creating a machine and destroying it might be like 1% of effort. I don't know, perhaps it's like 90 to 10. Because as far as I know that how runner works and how it auto scales, like there is a lot of business rules encoded in there. So that's just idea. It might be dumb idea. I just wanted to share.
So one thought on the let's not call this replacing Docker machine. I think probably a really helpful way to look at this whole challenge is we as an organization want to remove the need for Docker machine as part of the code. Like we think it's more maintenance and it's a bit of a support nightmare compared to not having it there. So big asterisk on we think, because maybe what we're finding out is worth keeping around. I don't think so, but just leaving the door open to that. What I think we're trying to do, and what I think Steve's getting at here, is let's make more attractive solutions so that the use cases that are currently using Docker machine, there's a more attractive thing for them to use, to the point where Docker machine is a feature that nobody uses, like the parallels executor. That was a joke. But let's can we solve the small dev teams problem in a way that's not using Docker machine, works better for them in some capacity? And then we've still got to solve the GitLab.com use case, the big deployments use case, all these reasons that people are using Docker machine. We have to kind of solve them and give them options, and then we can just remove Docker machine and no one notices kind of thing. You know what I'm saying? Just don't think of it replacing Docker machine. Let's provide a more attractive option to some subset of users. And then we keep doing that until there's no more steps left.
Yeah, I don't know. I think you have to tackle Docker machine, Elliot. I think the more subset of users, if you're a small shop, you can kind of hey, you could figure it out on AWS at some VMs. I think we have to tackle the Docker machine replacement at scale. I mean, we spend all our cycles just solving a small shop trying to spin up a few VMs for a minute number of jobs. I don't think we'll ever make traction on the big elephant in the room.
Well, I mean, maybe that's the elephant we go hunting for first. Let's solve it. Let's solve it for the big user. Let's solve it for us. And then we have a case study on why that works, and then we can do a bit of an examination, what sort of scale does it become impractical for, right? If I'm a 3-engineer shop, and maybe doing 3 concurrent builds, does it make sense? Is there a better solution? Is where is that line between that small model and the 6,000 concurrent builds that GitLab.com is running?
Yeah, and that's, for me, that's why I think if you tackle, and I'm not trying to pick sides or anything, but just from my perspective, if you tackle—
There are no sides. We're all on the same team here.
Points of view. I'm not trying to say I have a point of view, but from my perspective, the way I'm thinking about it based on my interactions with customers is, if today I had a very solid pattern at scale, whatever we define scale to be, and I'm going to use Gorgie scale, 2,000 per group, 2,000 runners per group. Let's call that scale. Max the threshold. If I had that pattern today in my conversation with the customers, and the customer says, well, hey, I'm not as big as that. I'm only the small shop. That, to me, I want the big pattern. I want give me the pattern for the 2,000 per group. Because it's easier to have a conversation with a smaller team that just has 2 developers. It's oh, you don't have 2 developers, just spin up a VM or install it on your local Mac. For me, I want to have the pattern for the 2,000, whatever we define scale to be.
And that's the reason why I think we should start with GitLab.com. It might be Kubernetes, it might be something else, but solving that problem for GitLab.com, because we know we need to solve that, is going to give us enough insight to perhaps reason about how to solve that for smaller teams.
Okay, how would you solve it for GitLab.com?
Like that's there are probably a few like ways. One obviously is Kubernetes. Another one might be an in-house build service that will do scaling on GCP. But yeah.
Do we have time for me to get a little bit ranty? Just
I don't think we have time for you to not get ranty. Go for it.
I don't really like any of this because it's no matter what
Classic
we do,
Aaron.
no matter what we do, we're going to end up re-implementing something that already exists in GitLab Runner because it solves so many problems. Like, so its job is to execute a task, but it's also an auto-scaling solution. And even though we've got a custom autoscaler, it still calls that autoscaler. It's not like the two are separate, and they perhaps should be. You know, our competitors, they seem to have like an agent, right? So, and that's its job is to execute a task. So if we applied that to Runner, and forgetting about it being a manager, it would accept a job. It would be able to maybe support running services. So you could almost join Runner and Docker together. Let's just say they're a unit and you give it a unit of work and that's its job. And then you deal with how it does that on every other platform. So if it needs to be auto scale, that binary that includes Docker, can run services, can execute that job, needs to run in a bunch of other environments. So in auto scaling groups, it's, you know, that instance ready to accept a job on a bunch of auto scaling instances in AWS. In Kubernetes, it's the same thing. It's a replica set that you can scale up. That's ready to accept that job. Because at the moment, we are auto-scaling an autoscaler. Like this solution, it's GitLab Runner that can auto-scale that we're putting in an auto-scaling group. We're not using it as an autoscaler when it's inside these, but it could be because it's still GitLab Runner. Does that make sense? I just feel like it would be easier if we could separate the two. So out of all the other executors we've got, Docker Machine is like the odd one out. Every other one of them seems to run locally. It creates a VM. It talks to Docker locally. It's the shell executor. Then we've got Docker Machine that connects to remote hosts for an auto-scaling solution.
Is it, to make sure I understand you correctly, isn't what I was suggesting using auto-scaling groups with GitLab Runner inside of that instance what you're describing, or am I misunderstanding you?
It is, but you are still you're still installing GitLab Runner, which is an autoscaler, right?
No, GitLab Runner is just using the Docker executor, picking up jobs and running it on that machine. The autoscaling is handled by...
I know, but GitLab Runner itself can be an autoscaler, right?
But not with this pattern.
I know, you're installing it, and you're not using it as an autoscaler.
Exactly.
But it's a really difficult story to tell because honestly, I think a lot of people approach this organically. They just want to say, this is GitLab Runner and executes task. I'm coming from a different background where there's an agent that you install. Let's say Jenkins. You know, you put Jenkins in a container, you put it in a VM. When you come from places like that, when you see GitLab Runner, your first reaction is just, oh, this is just a replica set. I'll just scale this up to 100 and then it will accept jobs. That's fine. And then you start reading the documentation and it's very confusing coming from that background because it is also an autoscaler. So I know that you're using it in, it's not an autoscaler the way that you're using it and you've made the auto-scaling separately. My point is, I think that we should always make it separate in every way that we deploy. Even if we end up still using Docker Machine rather than, you know, it's creating a VM where you'd basically push the GitLab Runner executor, not the autoscaler, to it to accept jobs and do its stuff locally.
Yeah, I think I understand what you're saying. You're saying that we should have a separate product that would be used to autoscale runners, whatever platform we install them on. But I feel like it's an orthogonal problem because basically it's, you know, how the autoscaler, however we call it, it's going to work. We still need to know what platform it's going to run against, and on which platform it's going to scale the runners.
I think that what I'm trying to get is that I would prefer it if we pushed that problem a lot more onto the customers, so that we just provide. I mean, I definitely think we should also provide an auto-scaling solution, and we need one for ourselves. But GitLab Runner's job of just, you give it a job and it supports the feature set of services running anywhere and executing a job anywhere. So sometimes people will do what Steve has done. They'll create auto-scaling groups and it just contains GitLab, the sort of executor side of it, to execute the job. Some people will create replica sets in Kubernetes and they'll just scale it to 100 and they'll have it accept those jobs. Are other solutions of auto-scaling, like the sort of custom autoscaler, would be a separate product that pushes that GitLab executor binary onto remote machines. It's really similar to what we have, because it is what we have, because GitLab Runner currently does everything. It's an autoscaler and this executor. So approaching this is really difficult. It's difficult to try and win an argument where this is the case, because the argument is every time it's going to be, but we already do that because we do everything already.
Yeah, but whether GitLab Runner is one binary or two binaries, it's kind of a different problem, I guess. It's similar in a way, but it's not, I think, the problem that we are actually concerned about right now. I might be missing something, so I'm sorry in advance.
I think it's just difficult to explain. I'm explaining it badly. Steve's auto-scaling group. Sorry.
I think what you're saying is like separating the concerns, right? Like Runner executes jobs, and there's something else that auto scales job execution.
Yeah, and I think that the custom autoscaler was like the wrong solution, because it's still GitLab Runner executing that custom autoscaler. Ideally, GitLab Runner would be just concerned with the execution of a unit of job that's in the script, the services that it runs. And we try to get that repeatable in a bunch of different environments, whether that's using Docker locally, micro VMs, or whatever, even inside of Kubernetes. If it's inside a Kubernetes container, you try to still have it support that same feature set of it can create services and run that job. And it's a difficult thing to do across different platforms in the same way, but it's a different problem to auto-scaling.
Okay, Aaron, I have a question, because you are saying constantly that GitLab Runner is calling Autoscaler. Are you referencing the Autoscaler custom executor driver?
And I guess Docker machine. They're the only two that I know about that sort of auto-scales, right?
Okay. So like Docker machine, right? It's an autoscaler inside of the runner. Runner keeps track on how much machines it have, should it create one or destroy one, and this is something that we wanted to remove with the autoscaler custom executor. The plan was that autoscaler will have the scaler, and runner will just talk with it, execute me this job. And what's happening with autoscaling is outside of it. And if we want to look on how to resolve GitLab.com scale problem, my question would be, what execution environments we would like to target? Because for now, GitLab Runner, if we look on it as a binary that runs locally, we have shell, we have VirtualBox and Parallels, we have SSH, we have Docker. I'm leaving Kubernetes and Docker machine executor outside because they are sort of autoscalers themselves. Do we want to support all of these environments, or do we want to focus on one of them, like shell or like container? Maybe even not naming it Docker, but container. Because with that, I would still push us to the concept of custom executor and custom Docker provider or container provider. Last time we've ended with the problem that we wanted to do this with Kubernetes, but with virtualization inside, and it's hard and we can't really move forward. but it could provide solution also for both the big and the smaller scale, because we could use what Steve now is working on, a simple AWS autoscaling groups to create, for example, Docker environments that single runner can tag with, or we can work on something more powerful that will create even more things. Or maybe we will end with the fact that AWS autoscaling group is enough to work for both 10 concurrent jobs and 10,000 concurrent jobs. And I would really look in this direction. Like, use the concept of custom executor and auto-scale the environment that is executing the jobs, not the runner itself.
So I don't know how much time we have in this
2
meeting.
minutes.
Just one idea occurred to me, and I think that in this particular case, we should invoke the architectural workflow. We should create a blueprint, and what it gives us is that it will like the architectural workflow requires an architectural evolution coach to be assigned, and currently it's a distinguished engineer or an engineering fellow. And I wonder if we would actually see it valuable to have an input from an engineering fellow or distinguished engineer in this case, because I feel like a bit we are walking in circles, and we might benefit from a decision made, and like it's better to move forward to learn more, get insights, than like, because I think it's extremely difficult problem.
Yeah, and that's what I have at my last point. Like, should we open up a blueprint? Because I was going through learning this process this morning, actually, and I mean, like, yeah, we need to take a decision at some point, and like a blueprint might give us a good way forward. But my question, like my goal from this meeting was like, what are we actually writing in the blueprint? Are we writing autoscaling groups, or are we writing Kubernetes? That was the idea behind this meeting, anyways.
Yeah, so I think it's like a blueprint starts with an issue in the GitLab architecture tasks, and that's the moment when I can help you with finding an architecture evolution coach.
Okay.
Help with defining what's the scope of the blueprint, how to do that. Perhaps this will help. So we can try and see what it gives us.
Yeah, I think that's a really good idea. I think even bringing in more people, someone at that level who's also a bit less in the weeds with the runner, is probably good. I don't even know who, like, I don't know how many people we have in that distinguished and fellow.
I can only guess who this person might be, but I would need to talk with Campbell first.
Yeah, I was gonna say, like, as I say those words, I need to put them back in my mouth. I think it's a good idea. Like, let's do that. Creating the blueprint. I keep forgetting that that's actually an official process, and not just a word we use for saying like, here's our plan. So let's do that. But let's wrap up this call. This actually might, if we think about this as like, if we pivot this a bit and like, how do we solve this for GitLab.com? This might become relevant for the call we have coming up in like another half hour. We might be able to like merge a couple of thoughts there and like a couple visions. Grzegorz, you're welcome to join that too if you want. It's around the like job scheduling side of CI job scheduling. Just
can you please send me an invite? I'm not sure if I will be able to join.
Yeah, I'll send you an invite. Yeah. Otherwise, I think let's wrap this up. Thanks, Steve, for setting this up. I'm sorry we ended up just ganging up on you.
No, more questions is better. Like if it's just a bunch of yes, no, it's not a good solution. So thank you. So I guess the next action point for us would be opening up a blueprint issue and start talking to an evolution coach so we can discuss this further.
Yep.
Does that sound good?
Yep. I think you should work with Trevor on setting that up, figuring that out.
Perfect. Yeah, thank you. Thank you all.
Thanks, Steve.
Thank you. It was very interesting.